Now chapter 5 of Exemplar, Continuity and Differentiability, example 19. If fx is equal to root 2 cos x minus 1 upon cot x minus 1, x not equal to pi by 4. Find the value of f pi by 4 so that fx becomes continuous at x is equal to pi by 4. Now this function is given to us, which is equal to root 2 cos x minus 1 upon cot x minus 1. In order to this function to be continuous, we know limit of fx as x tends to pi by 4 should be equal to f pi by 4. And here we are to find the value of f pi by 4. इस फंक्शन को x pi by 4 पे कॉन्टिन्यूस होने के लिए हमें मालूम है लिमिट ऑफ एफ एक्स एज एक्स टेंस टू पाई बाय 4 शुड बी इक्वल टू एफ पाई बाय 4 एंड हमें उस एफ पाई बाय 4 की वैल्यू निकालनी है. Now in order fx to be continuous, limit of fx as x tends to pi by 4 is equal to f pi by 4. Now limit x tends to pi by 4, instead of fx I am going to write this function root 2 cos x minus 1 upon cot x minus 1. I am going to simplify this function. Now this is equal to limit x tends to pi by 4 root 2 cos x minus 1. Instead of cot x I have written cos x upon sin x minus 1. Take the LCM of this denominator. I'll have cos x minus sin x upon sin x. Now this is equal to limit x tends to pi by 4 root 2 cos x minus 1 into sin x upon cos x minus sin x. Now this is equal to limit x tends to pi by 4 root 2 cos x minus 1 into sin x upon cos x minus sin x. I am going to rationalize this. For that, limit x tends to pi by 4 root 2 cos x minus 1 root 2 cos x plus 1 upon root 2 cos x plus 1 into this sin x, and again multiply 1 upon cos x minus sin x into multiply and divide by cos x plus sin x upon cos x plus sin x. Now this is equal to limit x tends to pi by 4 root 2 cos x minus 1 into root 2 cos x plus 1, that is equal to 2 cos square x minus 1. A minus b, a plus b is equal to a square minus b square upon root 2 cos x plus 1 into this sin x into cos x plus sin x in the numerator, and cos x minus sin x into cos x plus sin x is equal to cos square x minus sin square x. Limit x tends to pi by 4. Now here 2 cos square x minus 1 is equal to cos 2x. This is a formula for cos 2x. Here cos square x minus sin square x means cos 2x. So this is a formula for cos 2x. So instead of this I have written cos 2x. Instead of this I have written cos 2x. So limit x tends to pi by 4 cos 2x sin x cos x plus sin x upon root 2 cos x plus x cos 2x. This and this is cancelled. I am left with sin x cos x plus sin x upon root 2 cos x plus 1. On the next page, I'll write this and I'll do the calculations. Now limit x tends to pi by 4 sin x cos x plus sin x upon root 2 cos x plus 1. Now substitute pi by 4 instead of this x. So I'll have sin pi by 4 cos pi by 4 plus sin pi by 4 upon root 2 cos pi by 4 plus 1. This is equal to sin pi by 4, value of sin pi by 4 is 1 by root 2. Cos pi by 4 is again 1 by root 2. Sin pi by 4 is again 1 by root 2. Root 2, value of this cos pi by 4 is 1 by root 2 plus 1. Now this is equal to 1 by root 2 into 2 upon root 2 upon 1 plus 1. That is equal to 2 by 2 upon 2. That is equal to 1 by 2. So limit of fx as x tends to pi by 4 is equal to 1 by 2. For this function to be continuous, this should be equal to f pi by 4. So value of f pi by 4 should be equal to 1 by 2. So f pi by 4 is equal to 1 by 2. Hence for fx to be continuous at pi by 4, f pi by 4, value of f pi by 4 should be equal to 1 by 2. So that is the answer. This is example 20. Show that the function f given by fx is equal to e raised to power 1 by x minus 1 upon e raised to power 1 by x plus 1 if x is not equal to 0, and this is equal to 0 if x is equal to 0. This is discontinuous at x is equal to 0. So in this example, we are supposed to prove this function is discontinuous at x is equal to 0. For function to be continuous, we know limit of fx as x tends to 0 minus is equal to limit of fx as x tends to 0 plus is equal to f0. If left hand limit is not equal to right hand limit, even then this function is discontinuous. In this sum, we are going to prove left hand limit is not equal to right hand limit. First we will find left hand limit, then we will find right hand limit, and then we will prove that left hand limit is not equal to right hand limit. Now first we will find left hand limit. So limit of fx as x tends to 0 minus. This is equal to limit of x tends to 0 minus. We will write the function here, which is e raised to power 1 by x minus 1 upon e 1 by x plus 1. Now limit h tends to 0. This x is changed into 0 minus h, and this x is changed into 0 minus h. So we will have e1 upon 0 minus h minus 1 upon e1 upon 0 minus h plus 1. This is equal to limit h tends to 0, e minus 1 by h minus 1, e minus 1 by h plus 1. ये नेगेटिव साइन को, नेगेटिव पावर को अब हम पॉजिटिव में बदलेंगे. उसके लिए ये रेसिप्रोकल में लिखा जाएगा. सो लिमिट h टेंड्स टू 0, 1 अपॉन e 1 by h minus 1, 1 upon e 1 by h plus 1. Now this is equal to, instead of h write 0. So this is equal to 1 upon e 1 by 0 minus 1, 1 upon e 1 by 0 plus 1. 1 by 0 is infinity. So this is equal to 1 by e infinity minus 1, 1 by e infinity plus 1. Now e raised to power infinity is infinity. So this is equal to 1 upon infinity minus 1, 1 upon infinity plus 1. 1 by infinity is 0, minus 1. 0 plus 1. So this is equal to minus 1. So left hand limit is equal to minus 1. On the next page we will find right hand limit. Now limit x tends to 0 plus e 1 by x minus 1, e 1 by x plus 1. Now limit h tends to 0, e 1 by 0 plus h minus 1, e 1 by 0 plus h plus 1. Limit h tends to 0, e 1 by h minus 1 upon e 1 by h plus 1. Now limit h tends to 0, take e 1 by h common. You will have 1 minus 1 upon e 1 by h in the bracket. Similarly, take e 1 by h common in the denominator. You will have 1 plus 1 upon e 1 by h. E 1 by h, e 1 by h is cancelled. So you will have limit h tends to 0, 1 minus 1 upon e 1 by h upon 1 plus 1 upon e 1 by h. Now instead of h write 0. 1 minus 1 upon e 1 by 0 upon 1 plus 1 upon e 1 by 0. This is equal to 1 minus 1 upon e infinity upon 1 plus 1 upon e infinity. This is equal to 1 minus 1 by infinity upon 1 plus 1 by infinity. This is equal to 1 minus 0 upon 1 plus 0, and this is equal to 1. So in the previous page, we have found the left hand limit, which is equal to minus 1, and here we have found the right hand limit, which is equal to 1. So left hand limit is not equal to right hand limit. It means limit of fx as x tends to 0 minus is not equal to limit of fx as x tends to 0 plus. So function fx is discontinuous at x is equal to 0. So this is what we want to prove.